Hello, sir.
The screen is visible.
Sir, screen black ஆ இருக்கு சார்.
Just a minute, just.
எஸ் சார், ஸ்க்ரீன் ஷேர் ஆஃப் பண்ணிட்டு ஆன் பண்ணி பாருங்க சார். Now visible, sir.
Okay. So, good afternoon, sir. Good afternoon, students. Uh, in the third unit, we are already discussed about different type of nuclear power plant. So today we are going to discuss the final another one power plant, that is nuclear power plant. We are going to discuss, right? So first we will see the today agenda of the session. So in the introduction part, we will discuss about what is the importance of nuclear power plant, how the nuclear power plant is used to generate the power, and different types of nuclear reactors we were discussed. That is pressurized water reactor, then boiling water reactor, then Gandu type reactor. Everything we were discussed in the last class. So today we are going to discuss another one type of reactor, that is called advanced nuclear reactor. Okay. So in the last few classes we discussed about different types. So today we are going to discuss the advanced nuclear reactor. So what are the advanced nuclear type power plant? Nuclear reactor types used in nuclear power plant, that is we are going to discuss. So that is the today agenda of this session. So normally in the year of 1940, okay, the nuclear energy has been utilized because during that time the world war is happening. So all the countries they used, okay, the atom bombs and so many things. Okay, that is nuclear weapons they are used at the time. So that highly enriched uranium, that is atomic bomb, was using, okay, on that time. So with help of that uranium, okay, we can develop power also with the based upon uh, the war. Okay, after complete the war, okay, so the usage of uranium fuel is increased. So they used for weapons production, and also they used for power production also. Okay, so now all the countries focusing for nuclear reactor for producing uh, power. So they are using uranium as a fuel. So I already told how the nuclear fuel is so important because in fossil fuel normally coal or some other fuel means natural gases or some maybe diesel or some LPG or something, whatever it may be used mean, okay, it's amount generation of power, the power generation quantity is very minimum because it has only lower energy. But if you use a nuclear energy means with a small amount of nuclear fuel, we can generate more power. The, the power producing capacity may be increased, okay, rapidly. Okay, with the sudden requirement, we can go with nuclear means we can easily attain. So that's why we are moving to fossil to nuclear. And also nuclear fuel has some other disadvantage also, that is already we discussed. One of the problem is radiation. So we have to control the radiation. That's why now all the countries, okay, they're focusing the uh, nuclear power plant, and also they are focusing the control of nuclear wastage. Okay, so uh, uh, how to we have to save the people without radiation. If it is any leakage come out from your nuclear power, that means radiation is come out from your nuclear power plant, it will affect the people and the environment. So all the countries are focusing to protect the people with help of this effect. So they are very keen watching. Okay, all the peoples also. suffering with the radiation. So uh, the how to dispose the waste is playing a very important role. Okay, so these are the things you have to keep in mind. That is, we were already discussed in 2 or 3 classes how to dispose and what is the importance of nuclear fuel, all those things, right? So in the last class we discussed about different type of reactor, right? Pressurized water reactor we discussed, boiling water reactor is another one type, and GAN2, then phosphate reactor. These all are different types of reactor. So today we are going to discuss another one last type of reactor, that is a gas-cooled reactor. This is also an advanced one type of reactor. So gas-cooled is an advanced reactor. So if you before going to the gas cooled reactor, you should know what are the different types of material we are using. Okay, as a fuel mix, uranium U-35 is one type of nuclear fuel used, and the uranium U-38, thorium 232. These are the some of the predominant material nuclear fuels used in nuclear power plant. So if you see the radioactive life of fuel, you can see this slide. If it is a uranium U-35 is the life of the radiation. Okay, decay period, half-life period is 7.04 to the power of 8 years. So for a uranium U-35 is a natural uranium. It consists of 0.7 percentage, okay, uranium. Similarly, uranium-238, thorium-232 also have a nuclear fuel used as a nuclear fuel, and it has some decay period. If you see the half-life decay period is for uranium U-38 is 4.47 to the power of 9 years, and thorium is 1.41. So thorium is the highest half-life decay material, that is nuclear fuel. Okay, so these are the things you should know, and you should know the neutron interaction. That is, one nucleus is at touch with one of the nucleus of uranium-235 center part that will combine with one neutron. So that neutron combined with the uranium-235 means it will produce uh, beryllium and krypton. Based upon that, okay, high amount of heat energy is liberated, and another two neutron is developed with the help of the two neutron. Again, another uranium 235 is react with this, so the reaction is started. Likewise, the chain reaction is keep on is going. So high amount of energy is liberated. With help of the heat energy, we can develop the power. So this is the basic concept you know very well. So based upon that, we are classified boiling water reactor. So boiling water reactor, you have a heat exchanger unit, okay. But the heat exchanger, if you see, okay, it is inbuilt one. So your pressure vessel and nuclear reactor both act as a single unit in case of your boiling water reactor. If it is a pressurized water reactor, means okay. So your heat exchanger is a separate unit. So pressurized water reactor, you need a pressure pump. So with the help of pressure pump, water is circulated. With the help of that water, we can convert it into steam. With the help of heat exchanger, then that steam can utilize for power generation in turbine. So this is about pressurized. So 150 bar pressure is maintained in boiling water, sorry, pressurized water reactor. In boiling water reactor, so here no heat exchanger is there. Okay, your pressure vessel and your heat exchanging process both will be takes place in the vessel itself. That means your nuclear core itself, reactor itself, both it is happening. So the steam generation takes place in the reactor vessel. After that, the steam is goes to turbine, and again power generation is happened. Then the remaining steam is come up from your turbine, is goes to condenser. Then again it will condense. That means water are converted. Steam is converted to water. Then water is goes to again reactor. Likewise, it is goes. So this is about boiling water reactor. And next we discuss about the different components of reactor. That is also we discussed in the last class. So these are the different components. Here you can see how the containment zone, how the control rods place, okay, and the turbine how it is located. All those things we were discussed. Okay, and we discussed about the different type of nuclear reactors. Okay, based upon that how the fuel. is loaded in the reactor, that is with help of fuel rods. Okay, fuel is uranium-235, that is in the form of tablet that will be placed in the fuel rod. With help of that, the reaction will be takes place. So this is also we discussed, and the steam generator heat exchanger also we discussed. So around the water is flowing to the pipeline, surrounded by the heat gases uh, touches surrounded by the water tubes. So water gets heated up and converted into steam. Then it will goes to turbine. Likewise, the steam generator generates the steam. And this is about nuclear reactor. So these are the topics we were discussed. So today we are going to discuss the advanced reactor. Okay. So advanced first type of reactor is developed in Japan. Okay, it is a gas cooled type, high temperature type reactor. Okay. So 9 new reactor design either approved or advanced stage of planning, incorporate safety improvement and are simpler to operate, inspect and maintain repair. Why we call this advanced reactor means based upon the safety provisions. Okay, so how the safety is important, you know very well, because radiation is come out from possibility of radiation come out from your reactor. So by this way, we have to provide a safety improvement. Okay, so by this way, we can say it is advanced. So, sir, lot of improvement is takes place in the reactor. Based upon that, we are called as safety reactor or advanced reactor. Okay, and also some simple in operation and maintaining easier. All those things are incorporated in the reactor. That's why it is called an advanced reactor. So normal compared with the normal reactor, these type of advanced reactors are more safer, and easy to operate and easy to maintain, easy to inspect. All those things are some of the advantages of advanced reactor. The new generation of reactors have a standard design to exploit licensing, reduce capital costs, and reduce construction time. So, what are the main features of advanced reactors? One is the design is a standard one. Okay, it's a common design standard. Okay, so anybody can understand easily and reduce capital cost. The cost of your nuclear reactor also it is reduced by using uh, uh, flexible design approach and reducing construction time. So easy to construct. So what I'm trying to say is, so compare with the previous one, these type of reactors are easy to design and cost also reduced, and the construction time also is very less. That's why it is called an advanced reactor. And another key features are higher availability and longer operating life. So if you see the previous reactor, the life of reactor is time is very short period. But if you use these kind of concepts, that means standardized procedures of reactors and reduce capital costs, and uh, by using different materials for constructing the reactor, all those things. If you use main, okay, the advanced material if you use main, the reactor life is increased. That's why it is called advanced reactor. And most one thing, it is economical and competitive. Okay, high amount of heat energy is generated with the help of this reactor, and also the time period to operate the reactor or time period to operate the power plant is also very short. That's why it's we can call it as advanced reactor. And second very important point is a higher burn up time to reduce the fuel usage, the amount of waste. So by using this type of reactor means that completely the material used in the reactor is burned, and second one is high amount of energy we can liberate it, okay, with help of this reactor. So all those points are important in advanced reactors. Okay, so these points you have to keep it. So why we call advanced reactors? So it is more easier to construct, and it is capital cost is very less. Design is it's not a complicated one, and operating time is life is more economical one, and the competitive wide ranges. Okay, then accidents and repairs is very less, and we can produce more amount of heat energy with the help of lesser fuel. Amount of waste is reduced. So these things uh, are key features of advanced reactors. Okay, so next we are going to discuss about the advanced one type of reactor. This GAN2 type reactor is an advanced reactor that is also being discussed. Okay, so why GAN2 type reactor is advanced means the construction of your reactor is very simple comparative with boiling water reactor and pressurized water reactor. That's why GAN2 type reactor is a advanced type reactor. So GAN2 stands for Canadian Deuterium Uranium. Here, the deuterium uranium is used as a fuel, and it is a pressurized heavy water, okay, natural uranium power reactor designed in the year of 1950s late. Okay, the Canadian government first it is implemented this type of reactor. Okay, so our atomic energy of Canada, our India, okay, they are using Kudangulam, okay, they are using Canadian designers, okay, with the help of that they started the CANDU projects, okay. So CANDU is a Canada deuterium uranium, okay, okay, it's a type of reactor, okay. So this reactor is one of the advanced reactor. Here you can see how the reactor is there, how the fuel rods are placed in the reactor. Here you can see with the help of the fuel rod, the uranium fuel pellets is stored. Okay, so this is your reactor core. This is they are simple in construction. So with help of the concrete shell, okay, the reactor core is inserted. Okay, so with help of fuel rod, the fuel pellets will be placed on the fuel rod, and the rods are placed in the portion, reactor portion, and then portion is placed in the reactor shell. Likewise, the structure frame is okay available. So it is easier to operate, it's easy to maintain, and less number of accidents, more amount of energy we can utilize, more lifetime of fuel. That means we can more lifetime of plant or reactor. All those things are the advantage of Gantt type reactor. So you know how the Gantt type reactor is work. So with the help of this reactor core, okay, the chain reaction takes place. So high amount of heat energy is liberated in that area. So the water is sent to the area. So the water, the steam, okay, is goes to the steam generator area, and that water tubes are there. So water, the heat in the steam generator, okay, surrounded the steam is circulated around the water tube. So water gets heated up and steam will be generated. That steam goes to turbine, and the power production processes takes place. After leaving from the turbine, further is converted into water. So again, the water is goes to steam generated area. Again, the hot gas come out from the reactor core that will be surrounded with help of water tube. So automatically, water gets heated up, and the steam generation takes place in the steam generator. Again, the steam goes to timer. Likewise, the cycle is repeated. So this is a very simple reactor. So it has a Gantt type reactor and a reactor outer core shell and steam generator. So this is a simple one. That's why, okay. So operating is very easy to construct. Lesser time we can operate within lesser time of duration. We can operate the plant, and less maintenance, less parts, less number of parts also. These are the some of the advantages of Gantt type reactor. Next, we are going to discuss about gas cooled reactor. So gas cooled type reactor, here graphite used as a moderator. So how we are categorized as a reactor means what type of moderator we are using, what type of coolant we are using. Based upon that, we are categorized different type of reactor. So next advanced one type of reactor is gas cooled graphite moderator reactor. Okay. So gas cooled reactor is an nuclear reactor which uses graphite as a moderator and gas as a coolant. So here, you know, moderator is used. Moderator is the function of moderator, you know, is used to slow down the reaction of neutron. Okay, so the, based upon the neutron moment that you collide with the uranium-235 nucleus, the chain reaction is takes place. So if you want to slow down the neutron wave, the chain reactions rate of chain reaction is slowed down. Okay, that is the function of moderator. So here, what type of moderator is used here? Graphite modulator is used, and next one is gas cooled is used. Normally, carbon dioxide or helium is used. So it's generally heavy water or normal water is used as a coolant in pressurized water and boiling water reactor. But here the coolant is carbon dioxide or helium. So with help of this gas cooling, okay, we can operate the power plant. So these are the two differences between the previous power plant and gas cooled power plant. So and the most of the things are similar. Only the moderator and the coolant is changing. So far, increase the life of the reactor and increase the power production. So that's why we are introducing uh, two thing changes. One is the moderator is used as a graphite material and gas is cooling. Gas normally carbon dioxide or helium is used. Okay, in this type of gas cooled reactor, and remaining things are similar. So again, fuels are stored in the nuclear reactor with help of fuel rod. One nucleus is touched with the uranium 235, one neutron touched with the uranium 235 nucleus. So the chain reaction starts place. So more amount of heat energy is liberated. That heat energy can be generate the hot gas. That hot gas goes to the steam generator area. In that steam generation area, the water tubes is there. In the water tubes, okay, the water is passes. So around the water tubes, hot gases is surrounded. So hot gases has high temperature. That temperature is transferred from hot gas to water. So water gets heated up and transferred to steam and transformed to steam. That steam is goes to turbine to generate the power, and remaining gases is low pressure, low temperature gas come out from your turbine. That is goes to condenser through water circulation. Steam is converted into water. Then again, water goes to uh, uh, the reactor core with help of gas circulation. Likewise, it is goes. So okay, so that water is goes to cooling water circuit. Okay, and the remaining gas is low pressure, low temperature gas. That is go to the gas circulation area. Then gas circulation area again it goes to your nuclear reactor area. Again, the power, the chain reaction is takes place. So high amount of heat energy is liberated. So the gas uh, converted into hot gas. So normal gas is converted into hot gases. That hot gases again goes to steam generator. So water is surrounded likewise. Water gets heated up and converted into steam. So this process continuously happen. So power generation takes place. So what I'm trying to say is similar thing. Every type of reactor is similar thing, but what is the different in the construction of your uh, outer cell and what type of modulator and what type of coolant is used based upon that. Okay, it is differ. So these are the point you have to keep it. And one more thing you have to keep it in why it is advanced mean because of improvement of power plant we introduce best design of reactor and more lifetime of reactor and high productivity of heat and fuel usage, all those things based upon that we are telling it is a advanced type reactor. So a gas cooled type reactor is an advanced type reactor. With help of that, we can produce the power. So here carbon dioxide or helium is used as a coolant, and second one, graphite is used as a moderator. Okay, these are the things you have to keep in mind. Okay. So what are the advantages of gas-cooled graphite moderator reactor? Is first one, processing of fuel is simple. That is, I told, no corrosion problem. So here corrosion is not, because if you use water as a coolant means, okay, maybe a shell may be corroded, but here there is no, gas is used for cooling of reactor. That's why no corrosion problem. Okay, that's why we can call it as advanced type reactor. And graphite remains stable under radiation at high temperature. So here high temperature is produced, so graphite does not affect. So that is one of the advantage of gas cooled type reactor. That's why we go for graphite. Okay. And use of CO2 as a coolant completely eliminate the possibility of explosion in the reactor. So if you use some other materials, okay, some other gas means, okay, explosion is possible because due to high heat. But if you use CO2 means completely explosion is avoidable. Okay, so which is always present in water cooled plants. And uranium carbide and graphite are able to resist high temperature. So here we are using graphites and uranium carbide, uranium material is used, so it is able to resist the high temperature. That's why gas cooled graphite moderator reactor is used nowadays, and it is also called as advanced type reactor. So here you can see the structure of high temperature gas cooled reactor. Okay. And some other bevel bed reactor also nowadays used. It is used for cycled process like reactor purpose. They use bevel type. Okay. So these are some of the advancement. In bevel type reactor, helium gas is used. Normally CO2 is used in case of gas cooled graphite moderator, but if you use bevel bed reactor means, okay, here helium gas is used as a coolant. So these are the things you should have, you should know. So that's all from your nuclear reactor. So in this unit we discussed about what is the purpose of nuclear power plant, why it is very important, what are the different type of reactor, what are the different type of nuclear power plant is there, and each type unique advantages, disadvantages, working principle, everything we have discussed. Okay. So next class onwards, we are going to discuss about the how the nuclear fuel is taken care. Okay, how it is dissolved. Okay, how after usage. Okay, after producing the power plant. Okay, how the wastage is disposed. How the disposal method. Okay, that is we are going to discuss in the next class. Now you can see one video related to gas cooled type reactor. You will understand better. So please wait. I will show the video just a minute. If you have any doubt, now you can ask. So these all are the different type of nuclear reactor.
No doubt, sir.
Before understanding the nitty-gritty of the gas-cooled reactor, let's first understand the purpose of coolant. In this type of reactor, the coolant used is gas, namely hydrogen, helium, or carbon dioxide. The gas should be circulated at a pressure of 1.05 to 1.40 MPa. Mostly CO2 is used. Graphite blocks are used as moderators, within which channels are made for housing fuel rods. Channels are established between the graphite blocks for the flow of coolant. Graphite is less effective than water, which causes nuclear fissions on a bigger scale. For this reason, the gas-cooled core has a large volume to facilitate better heat removal. Another advantage of using graphite is it reduces corrosion and the thickness of the reactor shield can be reduced. Control rods are inserted into the graphite block. Natural uranium is used as a fuel and is clad in a magnesium alloy called magnox. Hence, this reactor is also called as a Magnox reactor. The coolant gas CO2 is supplied by a gas circulator and enters the core from the bottom. Gas flows through the coolant channels between the graphite blocks. As the gas moves up through the core, it gets heated up and leaves the top of the core at a high temperature and enters the steam generator. The tubes in the steam generator through which water is circulated should have fins on their surface to improve the heat transfer rate. The hot gas converts water to steam in a steam generator. The steam is then transported to a large turbine where it pushes the blades and turns the shaft connected to a generator. This causes electricity to be generated, which is sent across transmission lines to towns and cities. Steam from the turbine is converted back into water via a condenser and is pumped back into the steam generator. This kind of reactor can unload the fuel without shutting down and is safer, especially in case of accidents.
Okay.
You all must agree that we are living into a millennium where we cannot imagine our lives without electricity. With constantly growing population and our huge dependence on the electricity, it was very important to search for a sustainable and viable source of generating electricity which everyone can afford and use. And do you know what that source is? It is the nuclear power plant. It is a type of power station that generates electricity using heat from nuclear reactions. These reactions take place within a nuclear reactor, and the electricity made by these power plants is called nuclear power. Nuclear power plant includes numerous buildings and facilities. Important among them are turbine building. It houses several turbines as well as the generator necessary for the electrical power generation. Containment building. The nuclear reactor is housed here. This building is made of 1 meter thick reinforced concrete. Inside this building, nuclear reaction takes place. Cooling tower. It can be as tall as 200 meters. This is the place where hot water is cooled. In this module, you learnt about an overview of a nuclear power plant.
Hello guys, welcome to another tutorial by Supreme Tuber. In this video we will be discussing about nuclear power plant, its schematic diagram. Okay, so we will be discussing the schematic diagram of nuclear power plant. Okay, so the nuclear power plant, the process used in nuclei into water into steam, and this steam drives the turbine, and this turbine is used to produce electricity. Okay, so this is the process of a nuclear fission, and the currently
Nuclear reactor. In this video, we're going to learn about the nuclear reactor. Nuclear reactors are the modern-day devices extensively used for power generation, as the traditional fossil fuels, like coal, are at the breach of extinction. A nuclear reactor is the source of intense heat, which is in turn used for generation of power in nuclear power stations. Its mechanism is similar to that of a furnace in a steam generator. The steam is used to drive the turbines of the electric generator system. A nuclear reactor consists of three crucial components: fuel elements, moderator, and control rods. Fuel elements come usually in the shape of thin rods of about 1 centimeter in diameter and contain fissionable nuclei like uranium-235 or uranium-238. These rods vary in number according to the size of the reactor. In large power reactors, thousands of fuel elements are placed close to each other. This region where these fuel elements are placed is called the reactor core. These fuel elements are normally immersed in water, which acts as a moderator. The objective of a moderator is to slow down the energy neutrons in a nuclear reactor, which are produced during the nuclear fission process by the fuel elements. Thermal neutrons, which are the neutrons with energy of about 0.04 electron volts, are capable of producing fission reaction with uranium-235. During the fission reaction process, new neutrons are given out, which have energies of about 1 MeV. This is 1 mega electron volts. These neutrons typically escape from participating in another fission process as they are accompanied by enormous energy release. In fact, the probability of these neutrons produce another fission reaction is 500 times less than that compared to a thermal neutron. This is where a moderator is extremely useful. Moderators have the capability to slow down, or in other words, moderate, the speeds of these high-energy neutrons so that they can in turn be used for a chain reaction to trigger multiple fission reactions of other uranium-235 nuclei. Commonly, ordinary or heavy water is used as a moderator in nuclear reactors because of the deuterons present in them, which are capable of slowing down the neutron speed. Water molecules in the moderator are useful in slowing down the high-energy neutrons, which leave the fuel element after nuclear fission. These high-energy neutrons collide with water molecules, thereby losing out on some energy with every collision and therefore slowing down substantially. A new fission reaction can now be triggered using this slow neutron by striking it with a fuel element. The third and most prominent part of a nuclear reactor are the control rods. In order to get a steady output of energy from the nuclear reactor, every single fission reaction should trigger another fission reaction and ensure the availability of spare neutrons released to trigger the chain reactions. By controlling the number of spare neutrons available at any given time, the rate of nuclear fission chain reactions can be controlled. This control on the fission reaction can be maintained using control rods. The main function of the control rods is to absorb any excess or spare neutron in the moderator in order to prevent any further fission reactions. Usually, such control rods are made of boron or cadmium. To increase the rate of fission reactions, these rods can be removed from the moderator. A steady output of energy can thus be maintained by inserting or removing the control rods in the nuclear reactor. Now that we know the components of a nuclear reactor, let's understand the working of a nuclear reactor. It's usually enclosed in a shield made of thick concrete walls. It consists of a reactor core, pump, and heat exchanger. The reactor core and pump are placed in contact with the water, which is usually the heat exchanger in these reactors. Due to the enormous amount of heat released during the fusion reaction, the surrounding water gets heated up and changes to steam, which is in turn used to turn the turbines. So huge heat energy gets converted into electrical energy. Water is continuously flown in and out of the nuclear reactor using the pump. So a nuclear reactor successfully generates nuclear energy from fission reactions.
So, any questions related to nuclear power plant? Are you
No,
clear?
sir.
Nuclear power plant?
Yes, sir. Clear, sir.
Okay. So maybe okay, any type of power plant may be asked. Okay, in your examination. Some, for example, explain Gandu type of reactor, how it is working, how with the help of Gandu reactor power can be produced. Likewise, the question may be asked. So you have to work out for the Gandu type reactor. So construction, working principle, and diagram is very important. Similarly, you have to prepare all type of nuclear power plant. Okay, so this is very, very important in terms of examination. So that's all from now. You have any questions now? You ask. Otherwise, you can leave. Thank you. Thank you so much.
Thank you, sir.
Thank you. Thank you.